In this video, I'm going to talk about the linear probabilistic modeling. This video is going to be divided into three parts. First, a very simple explanation. Second, I will give examples about it. And finally, I will go in more details about the formula. On top of the image, you can see the definition of the linear probabilistic modeling from the book. In other words, LPM is a tool that extends the concept of something called linear regression model, and from it we get a formula that simply gives us a yes or no in the form of zeros and one, depending on another variable, which can be something like temperature, income, time, etc. We use these yes or no results to calculate the probability for whatever variable we're considering. Examples of the linear probabilistic modeling. Let's start with something basic like a high school student going into college. If we set the variable as the parent's income, we can calculate the probability of students going into college depending on their parents' income. We have some more complicated examples like calculating the probability of traffic on snowy days. That variable can also be a rainy day or sporting events. And in the engineering world, linear probabilistic modeling can be used for something like the probability that a chair that is being produced by the company and will break depending on the weight and time that someone sits in it. So we would take samples of people sitting in the chair and calculating how long it takes to break, and then we can have the probability of whenever a chair is going to break at a certain time. Take a look at the formula. B naught gives us an estimate of the y-intercept and true regression line. B sub 1 gives a least squared estimate of the slope and the true regression line, and it can be either positive and negative. A positive value represents a positive relationship, and vice versa. The mean of epsilon is equal to 0 and the variance is equal to the variance of the population. Epsilon represents the distance from the points to the regression line. As you can see in the image, the points below of the line represent a negative value, which often means failure or deny, and the points above the regression line means success, positive, or approve. Down in the image, you can see the formula to calculate the regression line. Thank you for watching.